Two.
Good morning, everyone.
Morning.
Morning, Professor.
We'll give a couple minutes for everyone to join in. Anyone wants to start with any security news of last week? Any big things you guys came across?
Amazon had a little issue.
That's right. Were any of you guys affected? I guess Canvas was down for a little bit, right?
Yeah, Canvas disappeared for the better part of the day.
Can someone tell me, was it a security issue?
No.
What issue was it?
They broke their DNS.
Availability issue.
Nice. Yeah. Did anyone read like a technical deep dive on it? Any deep dive you guys liked or came across? All right.
I didn't read it, but it looks like Wired had one, and it looks like The Guardian had one.
Yeah, that's right.
They updated the API for their Dynamo database, which is the DNS resolver. And so then when websites were trying to send people to the right IP address, it didn't know where to send them. And all of those DNS resolutions had to be recreated essentially.
Nice. Sweet. Awesome. Any other security events people came across? Anyone else?
Or something about a big jury heist in France.
A jury. Oh, a jury heist. Do you have a link?
See if I can pull it up.
Hello. Sorry, I was late. I missed the question. Could you please?
We're talking about security breaches in last week. Anything you came across which caught your attention?
There was one I read about 900 plus gigabytes of data hacked from Israel's. I tried to look it up, but I read it during the week on Facebook.
I see.
It was
Um,
all video footage and stuff. It was 900 plus gigabytes.
let's see. Carlton has
There's a news article.
oh yeah, that's right. Yeah, the heist at Louvre. This one. Did anyone look into this one? There was this was very much the what's the Netflix show on heist? Do you guys have any guys has anyone seen that show?
Money
The
Heist.
yeah, Money Heist.
Spanish. Yeah.
Yeah, that's right. That's right.
Mm.
So this is Money Heist in real life. Hmm. Nice.
Nice.
Cool. See. Did anyone look into how this exactly happened? Or what did they do?
The only thing I heard was that they used a ladder to go up a couple floors and effectively like bypass all of the serious security by like breaking in a really old window that was far less secured than other access points.
Yeah. So you can make your safe really high tech and secure in the front, but maybe the wall of the safe is still old and someone just punches through the wall, right? So yeah, no, that's a good lesson on security is the whole package, not one thing, right? Nice. Anyone else? Like maybe we'll do one more or a couple more.
There's a critical TP link router vulnerability.
Yeah, they are a source of security bugs. TP link. That's right. That's right. So I will maybe share like this is since a lot of you guys how many of you guys use like cloud code or AI agents or something like that?
What's Cloud Core?
Cloud the
Oh,
Anthropic,
Claude.
yeah, cloud code.
Hmm.
So let me share a couple. I'll share a couple different ones since you're interested. So this is an interesting one. Is you can basically use prompt injection in things like Claude Code to get access to a user's machine. So this is an remote code execution. RC stands for remote code execution in AI agents. So this was published by Trail of Bits. So this is a pretty interesting attack um, on a CLI based AI agent. So this is a good one for you guys to be familiar with, as you will see more and more breaches along these lines. How many of you guys heard about the OpenAI browser? Did anyone try it?
Atlas.
That's right, Atlas. so that browser also has an agent inbuilt into it, and so you will probably see things of this nature come through, but more so, these are very prevalent in agents which have access to your local files. So this is a pretty good technical deep dive, so I encourage you guys to read it. And then one which is more from a defense perspective, let me pull that one up. There you go. So, um, so the Department of Treasury, let me see. Yeah, okay. Was able to bust a pretty big cyber criminal network in Southeast Asia, um, which used money laundering with crypto. So they actually were able to track uh, the whole operation and actually freeze their accounts. So over $16 billion of a scam done by this group in US and UK. So this is on the blue team side of things, but at the same time, this is a good article on how they were able to track them. Uh, they uh, they did a lot of analysis of their wallets, crypto wallets, and were able to kind of map uh, uh, all the identifiers associated with these scammers, and finally find who they were. So this is a pretty big success for busting a crime gang. So this is a good um, blue team development. Sweet. Awesome. All right. Okay. How was first week for you guys? Let's talk about, yeah. So I know last week we kind of talked a little bit about Wireshark. We will do a little bit of a review. I know we were trying to get Wireshark up and going, but I will start the class today with that. How I see that majority of you guys finished your case study. How was the case study? And we'll discuss the case study as the second item in the class today. How was the case study?
It was good for me. A lot of information.
Yeah, it was interesting.
Yeah, he was very interesting person.
Yeah, extremely interesting.
Yeah, yeah.
Yeah, so we unfortunately lost Kevin Mitnick last year, I think.
Yeah.
Yeah. So
But
yeah,
it's
so
very,
yeah, so we'll talk about the case study. For people who have not completed the case study, I encourage you guys to finish it. It's important for you to keep uh, turning in your work. So please do that. All right. So maybe we'll just talk a little bit about Wireshark before we jump into Kevin Mitnick. And then I know some of you guys try Hack Me. How was the prerequisites? How did you guys find it?
for me, that I didn't know anything about hacking. So it was very good for me. I tried the first chapter of Fantasy. So I learned a lot.
Okay, I highly encourage people to continue doing it, especially if you're new to all of this or this seems like foreign to you. Encourage you guys to actually work through the whole prerequisites track. That'll just kind of make it easier. Also, you will kind of build, even if you know a little bit, but not are a solid footing, I encourage you to complete it. It's just going to build your basics. Cool. Yeah, I'll start with maybe just a little bit of motivation with Wireshark. So, this is sort of Wireshark uh, running on my machine, and I want to kind of show a couple things here, right? And so I'm going to use Wireshark to look at everything running on my Wi-Fi interface, right? I can do other things as well. So my Wi-Fi interface here is Wi-Fi EN0. So I sort of started. And last class, we talked a little bit about like different layers of the OSI stack and things like that. But what you're seeing is like all this traffic as it's sort of going through my computer. So I'm going to maybe pick one here, and you will see the source of this traffic is this IP address 172.16.0.6, and the destination it's going to 144.195.15.18c, and the type of protocol it's using is UDP. And it sent 303 bytes. So if you sort of, this is one way to look at Wireshark, where you can kind of look at everything in the traffic, okay? And then what I'm sort of looking at it as on the packet level, right? And so this packet, I can kind of break it as per the layers of OSI, which is like we talked a little bit about it last class on like, on the networking layer, what exactly happens. At the lowest level, you will see these the length of the data. So the length of the data was 261 bytes, and rest of the data was used for like capturing packet information, right? Like so about 40 or so bytes were used to kind of describe this. But if you see, this is the data which got sent, and you will see this is sort of the data. But on top of the data, there is this user datagram protocol. And if you click on that layer, so at the very core bottom layer is the physical data, then it's the user datagram protocol. You will see the source port for that is 61374, and the destination port is 8801. And that is described by this, it has a checksum. You will see this is the checksum of the data. Then there is like a stream index, stream packet number, and then there are timestamps of the data. So this is the UDP protocol. So what layer is UDP at? Can someone tell me? We discussed 7 layers, but in practice, there are usually only 5 layers of TCP/IP or internet, if you will. What layer is the user datagram protocol? And I will maybe bring slides from last class, and let's see. Yeah, there you go. So what layer is UDP?
Transport.
Jinx.
Right? So you will see like, this is like a textbook or theoretical model. TCP/IP is how the internet kind of works. So UDP is at transport layer, right? And so let's talk about it a layer below. So this is the internet protocol. So you will see it's got in the data in this protocol is this the one which is highlighted on your screen. So what internet protocol version is this packet being sent on?
Version 4.
That's right. You will see version 4. The source is this, the destination is this, and you will see that the big difference between UDP and the source, what's more important on the internet protocol is this 172.16.0.6. What is that?
Does that mean it's on the internal network?
Yeah, that 172 are internal IPs. But what is it? What does that number mean? Or
It shows the destination. It's a kind of like navigation, which destination and which route to take, and which IP
right.
address.
Yeah, so it's an IP address. So what the IP address basically stands for, like every computer on the internet gets a name. So this 172.16.0.6 is the name of the computer on the internet, right? And so think of it as that as the name. In UDP, you saw the ports, right? The ports are the names you're sending data between ports. So on these, you will see the destination address is 144.95.15.187, right? But the key things on internet protocol, you will see that, it's got a header length, which is it tells you the header is 20 bytes, 45, the uh, that if it has any differentiated services, total length of the data which is underneath it is 289 bytes. That includes the data for UDP as well, right? So the actual data is 261 bytes, but then the additional data is for UDP protocol, right? So this is the IP version. Can someone tell me what's the next version of the IP protocol? What's the one which is new one?
IPv6.
6.
That's right, IPv6. Cool. And then IP, what layer is IP protocol on?
Transport?
Let's go. What layer is the IP protocol on?
Well, network.
That's right.
Internet, yes.
Yeah, internet or network,
Network.
right? So let's take a look at the Ethernet layer. So this is actual, I have on this computer, my Ethernet is Netgear, and it's got this MAC address, right? And then the source of Ethernet is this MAC address, and the destination is this Netgear 9C3, etc., right? So it's going from my computer, which is 192.172, which is internal computer with a MAC address of this, to the Ethernet of Netgear router, whose MAC address is 9C, etc. So what's the MAC address? So you will see like this, you will see pretty much just the MAC addresses in this layer.
That's the name for each hardware component.
Is it a
Right, so
machine address code?
Yeah, it's a network card. Basically, it's the network card, which it's name of a card on the network. So the card might be in a computer, it might be in a router. So it's usually globally unique. So what layer is this at?
Would it be data link or physical?
It is data, yeah, it is both. Data link is part of physical layer. So, you're linking one computer to another physically with Ethernet, like, um, so this would be a data link layer. And then at the very lowest layer, which is all the 303 bytes being sent, what what layer is this at?
Brains is in the data link, in the link, yeah.
That's right. Yeah, you will see that, this is basically, this data being passed on like literally the physical layer, where it's like, these are from this interface, which is on Wi-Fi, it's getting passed to the router, right? So it's basically a UDP packet going to the router. Sweet. Let me see. Um, and I had given you guys a homework, if any of you guys remember, to see, to find out what new protocol you might see on your computer. Did anyone come up with the name of that protocol?
Quick.
That's right. Good job. So let's see if I can find quick. Okay.
I've never heard of that before. Is that brand new? Like, how often do they use that?
So let's see. Let's see, where did it go? First pick. Okay. Uh,
You had one there, QUIC.
yeah, it is there.
You just scroll down.
Might be easier to do it this way, but let's just do it this way.
There it is.
All right. Okay. Uh, and let me. Okay. There it is. Okay, it's underscore WS. So, okay. So what I'm doing here, and this is like a easier way to do Wireshark filters. So basically I said, hey, I'm only interested in all the packets on the quick protocol. So some would ask me how prevalent it is. What do you think? So this is this is on my computer. It's happening, right? So I'll give an example. So like while this is here, so it's like it scrolls, right? So let me see if this works. Let's give an example. Let's go to google.com, right? I just went to google.com and you will see that. So can someone tell me, just visiting that web page, did it use Quick? Yes or no?
Yes.
So how prevalent do you think this protocol is?
Very common.
Oh, sorry, go ahead.
I just said it's very common.
Yeah, so this protocol is like, it's Google prefers using this protocol because it's a little bit faster and more secure than TCP/IP. And Google invented this protocol. It's a standard now, but most Google properties use Quick. And you will see that very common, and a lot of other companies are also using Quick. But the big difference you will see here is like, Quick sits on top of UDP, whereas HTTP, which is what you would use on a normal website, sits on top of TCP. So that's a very big difference here. You will see, like, so this is why it's kind of useful to kind of learn this more hands-on and look at it. You will see, oh, Quick sits on UDP. It doesn't sit on top of TCP. So if we go back to the layer here, where do you think here Quick would be?
Above UDP.
Above UDP. That's right. And that's one of the big differences, whereas HTTP or HTTPS sits on top of TCP. Okay. Cool. All
I have
right.
a quick question before we go. Does TLS, is that specific to TCP?
Yeah, so where do you see TLS here?
I don't see it.
Yeah. So this is, I'm gonna, okay. So this is TLS version 1.2. Where do you think what's it sitting on top of?
HTTPS. So I would guess that would be TCP.
That's right. Right.
Are there any other encrypted UDP protocols?
There is DNSSEC, which is encrypted and on top of UDP. All right. Does anyone see anything interesting about TLS 1.2 here?
It's shorter, I guess.
Um, but, so it's very specific. You will see that it's 1.2 and there is no other TLS. There is also TLS 1.3, but it's sort of very rare to see that. You will, let me see if I can find one. There is, so 1.1 is broken in a way, like it has been hacked already. So that's the big reason, like it's 1.3, whereas other protocols you don't see their version numbers in them, right? Like, so if I said like the protocol was, let's say, quick, you want to see the version number. Let me see if we can find protocol ARP. Like, is there an ARP packet here? Oh, yeah, there it is. So there's no version numbers there. Can someone tell me what ARP? This is a very interesting protocol. This protocol is like the one which usually leads to a lot of like network compromises and the one to watch for. Can someone tell me what ARP stands for?
Is it address resolution
Address,
protocol?
yeah.
That's right. And then you will see what layer it is on. Here, where is it at?
Network.
That's right. And so what is it? Look at the packet and can you tell me what the packet is trying to do?
It's sending a broadcast.
It's confirming the who has the IP address, the
That's right.
address.
It says, hey, you see, this is a MAC of this Dell MAC address, and it's saying, hey, my IP address is this. And right. So it's resolving an address, right? So it's so if you're updating these tables all over your network, then ARP, address resolution protocol, basically kind of says, hey, I'm here, my name is John. And then some table maps like, this person who showed up right now is John, right? So that's the the main use for it. But then basically, if Sam shows up and he says, I am John, then people are going to start addressing him as John and sending him packets which are meant for John. And that might, like, that's one way. This is the key protocol which is sort of used, like, you heard a lot about, like, going into like a public Wi-Fi and people are able to snoop on into you, kind of do ban in the middle attacks or stuff like that. So a lot of those rely on ARP because they kind of come in and then say, hey, I'm google.com or something like that. And then they start receiving packages for that. It's not as simple as that, but like I'm simplifying it. But basically, that's why this is a this is one of the protocols to watch out for if you are looking in your network for if someone kind of snooped into my network and is trying to read traffic or things like that. You kind of see, is there any anomalies in the ARP traffic? So can someone describe me if you were to make an intrusion detection system which figures out like stuff like this on a very high level, what would you try to do? Like, how would you figure out if people are trying to spoof names or addresses?
Maybe ARP data coming from outside the network.
Yeah, just sort of think of like, what would you, what type of system you want to build so you can see um, intruders on your network, especially as it pertains to ARP or ARP packets.
I would say considering their MAC address as well, because someone could like spoof their IP and set up their IP the same.
You can
So
spoof the
ARP
MAC
could not
address.
detect it, so we can like always check for the MAC address that it's reaching the right person.
Yeah, I would maybe encourage you to just think in very broad terms, don't think very technically, but what would you do? So if you have a town and then there is a bunch of people who are running around in the town, and over time you know who is home, and then if you have a new person showing up and they sort of say they are someone existing, how would you build a system or where you kind of try to figure out like any of these attacks in on your town? How would you do that? What's the underlying thought?
I think we should label these ones or inform our staffs that this persons is in society and they are dangerous and you know.
Yeah, let's say so for example, this is um this is like maybe an Alexa ARP, right? So this is Amazon thing. It's saying my IP address is this. So at core of any intrusion system, what you want to kind of do is you want to kind of be aware of your base patterns. So for example, like, when your network's running, you're like, oh, John usually is this IP address and this MAC address. And then, this device is usually this IP address and this MAC address. And people can change things, but you know that they are in your system. But let's say now I have someone join this Wi-Fi and it's a Raspberry Pi which got just dropped into my Wi-Fi, and it says, I am Alexa. I'm Alexa's MAC address. Um, how would my intrusion detection system say, oh, that doesn't sound right? What would I do to kind of
You could set an alert to look for any changes to the local IPs and any new devices.
Yeah, so you might have a list of like whitelisted MAC addresses, right? And then if a new device shows up and says, I am one of those MAC addresses, so if someone in your time shows up and says, I am the mayor of this town, and you already know who the mayor is and what the mayor looks like, then you're like, no, that's not right, right? So ARP, that's kind of one of the things you would do in your intrusion detection system is you would be like, oh, I don't think so, because that's not the pattern I see on my network, right? In the past, from the traffic I've seen, from the things I've seen. So that's one of the ways. So this kind of way of doing it is it's sort of like anomaly detection, where like the usual person who does this looks like this, but then a new person shows up and they say, I am the mayor of the town, then you're like, no, that doesn't sound right. So yeah, that's exactly what you would do on the network here as well. And a lot of things we will see are kind of doing that on a technical level, right? Like you will come up with rules, you will come up with ways to kind of, pattern match and find anomalies. So we'll talk a little bit about that. Cool. All right, sweet. So that was from last class. And then, so let me show you one more thing while we are on there, and then we'll jump into another. So let's take example of TCP. Let me see. Okay, there you go. So, you will see TCP, there is a lot of interesting stuff here. There's a lot of TCP activity happening, but TCP is like this three-legged stool. A TCP has has a SYNAC mechanism. Is anyone familiar with the TCP three-way handshake? Can someone describe what a TCP three-way handshake is?
Yeah.
It's like calling someone's phone number and talking to them, and if they did not answer, that means that connection cannot be made different by sending the text. That was an example.
Okay, right. Anyone else?
Yeah, sending just like echo. So when you get acknowledge from that receiver, then you gonna start sending the data. So sending echo, get the request, and then you start sending data.
That's right. Yeah, so you basically call someone, and if they don't say hello, then you just hang up. If they say hello, then you are like, how are you, etc., etc., right? So this is very unique about TCP. It won't send data until it knows the other side is listening. UDP doesn't do that. So this is sort of called the TCP handshake, the SYNAC handshake. And so, this is what you will see. A lot of these like very short TCP packets are like the SYNAC packets, right? Like, and then TCP sends sequences and kind of keep tracks of all of that, right? So this is unique about TCP. That's why it's a little bit inefficient. That's why Quick was built on top of UDP and not TCP. And so TCP has a SYNAC mechanism. Okay. All right. Okay. Cool. Okay. Sweet. So let's maybe talk a little. Any questions on this? This is sort of what we covered last class. And then maybe one thing which we talked about, we didn't go deeper last class, was bytes and octals. Maybe I'll talk a little bit about it today. So what's a byte?
0 and 1.
8 bits of data is called a byte.
That's right. So 8 bits of data. What's a bit?
A bit is the smallest size of a data.
So it's whether it's a 0 or a 1.
0, 1.
Right.
Yeah.
Yeah. What's a nibble?
4 bits.
That's right. So nibble is like half a byte or 4 bits, right? So this is like, and so let's maybe talk a little bit in terms of numbers, right? Like, so if it were like 5, in binary, 5 would be written as 0, 1, 0, 1, and that would be represented as a nibble, right? Like it's only 4 bits. If you were to write 5 in octal, it will just be 5. But like, for example, 11 in binary is 1, 0, 1, 1. And then 11 in octal is 1, 3. And 11 in hexadecimal is B. Are you guys familiar with the translation of like the base systems here?
A little bit.
Okay. So, hexadecimal, you count from 0 to 15 as, 0 to F. So anything after 9, you say A, B, C, D, E, F. And so F in hexadecimal is the number 15. In octal, you count up to 8. So, you count from 0 to 7, and 8 in octal is 1, 0. Okay, so it's base 8. Octal is base 8. Hexadecimal is base 16. Binary is base what?
0 and 1. 2.
Yeah,
2.
base 2. That's right. And decimal is base what?
10.
Right.
Yeah.
So that's the thing. And so data, when it's sort of sent, it's, of course, data on the wire is always sent in binary. That's what computers can do. But very many times when you kind of open up like a weird PDF file, let me see, and then you kind of look into it, let me see. Yeah, I'm just going to say, yeah, so if you will open up like a PDF file in like a text editor, you will see these like hexadecimal things in it, right? And so that is a representation of the binary data. So how things are encoded on the disk are usually in hexadecimal. Okay, so the way computers store data is hexadecimal. And you will see there are other ways when data gets sent on the wire. There are encodings. So different types of encodings. There is UTF-8, there is Unicode, there is HTML encoding and such. And so, but end of these encoding are represented in hexadecimal. Okay. And hexadecimal on the wire is always binary. So keep that in mind because you will see data flowing in, like, for example, Wireshark. Let me pull up Wireshark here, right? So this here, what is this? So this is hexadecimal, like these 9D, you see D here, right? C3, it's hexadecimal. So BB, for example, is how many bytes?
11 and 11, 22.
It's 1 byte, right? And it's 2 nibbles because one hexadecimal number. So this is each 1 byte. So here, like, when we are counting the bytes, it's usually hexadecimal is 2 digits is 1 byte. Okay. And on the wire, it's being sent on bits. Okay, so the 0 and 1, and 0 to 15 requires 4 bits,
On the
right?
right
So
side, is it the translation of it to ASCII? Like the 45 is highlighted and you see the E is highlighted on the right side of it too.
yeah, so that's the encoding. So this is ASCII.
ASCII. Okay.
Yeah, but it could be different types of encoding, like HTML encoding. It could be UTF-8 and so on and so forth, right? But this one just does ASCII here at the moment, but it would probably do UTF-8. I think UTF-8 is what it does. But UTF-8 has ASCII as well. Okay, so cool. All right. Let's keep going. Any questions on all of this so far? Yes, no, maybe. Okay, all right. So let's maybe talk a little bit about Kevin Mitnick, and then we'll take a break. What I want to maybe sort of do is, we'll talk about capture filter, display filters after this. So can someone describe the background of the Kevin Mitnick case studies? Like who was involved, what motive was there, and then how did he go about, on a very high level, do the attack?
His name was Kevin, last name Mitnick.
And who did he
He-
hack?
The first try, he tried to convince the bus driver, telling them where to get those bus vouchers that are like for daily passes. And then once he find the location of the building or the administration that was issuing those vouchers, he tried to look their dumpsters and trash bins to find the, expired or like the trashed extra vouchers and use it the next day. That's how we started, I think.
Okay. Yeah, someone else wants to try?
His target was Shimomura.
Mm-hmm.
And he targeted him because Mitnick was on the run and he wanted Shimomura's Shimomura was a computer systems security expert and he wanted his technology so he can still be on the run as a fugitive. Also because Mitnick also wanted to target him because he found it as a challenge and he saw it as a hobby to like break into systems.
Right. And so how did he hack Shimomura?
I think he did it in like a few stages, right? He discovered like his X terminal through another server and then he analyzed the connection and then used TCP and made kind of used the SYN flooding attack with that TCP uses, like the SYN ACK I think we were talking about. Sorry, I'm not very clear on it right now.
No, that's great.
And
Yeah.
then I think he made sure that his device was trusted, and then he got his tech from there. I think I'm missing a few stages.
No, that's great. That's great. Yeah, anyone else wants to try?
I think he used baking network IP address for him for Shimomura, and actually spoofing and social networking, like social engineering, like I just I remember the title of phone clone and yeah, that's it. Phone clone, spoofing, and social engineering. Yeah.
Nice.
And
Nice.
the thing is about Mitnick for me is that money wasn't important for him, and just challenging is good.
Yeah, no, true. Awesome. Someone wants to talk a little bit about how would you detect or prevent an attack like what Kevin Mitnick did to Shimomura?
Well, personally, Professor, I think Kevin exploited just weakness in cybersecurity because it wasn't a field back then. It was mostly about just keeping networks up and just having communication between the nodes. So I think just training, the way that training is done today in enterprises on cybersecurity, I think would have made it very challenging for Kevin to be able to implement his attacks.
Yeah, so education is one of those. Yeah, that's true. If the systems were in place, you could have detected what he did early on, right? Even if he hacked in, you could have detected. That's right. Yeah.
I think Shimomura, but in case of your question, oh, wait, that's
Go ahead.
no, I just want to say that how Shimomura got him.
Yeah.
It was your question, yeah?
My question was, how would you detect and prevent an attack like what Kevin Mitnick did? Like,
Oh,
you
okay.
know,
Right.
so yeah, cool.
Sorry, can I add to that?
Yeah, go for it.
One thing I wrote in my analysis was that defense in layers is very important. So like in his attack, he had various stages of his attack. So like having defense in layers, like you could catch him in any stage of the attack. So if he just gets passed through one, you have another layer. That's what something I wrote.
No, that's
And-
great. Yeah.
And training staff is very important because the biggest thing in our network is that it's people.
Yeah.
If I'm not mistaken, I read he did something like a sequence prediction. And the way he did it is he um how do I explain this? But uh he kept sending a bunch of different sequences to figure out the pattern or so. Like it I guess to kind of get around the TCP protocol. And it, I guess if there's a way that you can see someone trying over and over and over again, but unsuccessfully, somehow set a red flag that, hey, there's someone twisting the doorknob over and over and over again, uh, trying to get in, if that makes sense.
Yeah, no, he did a sin so this is a here you will find like a very good detailed sort of explanation of the attack here. This is the Kevin Mitnick's you know what he did with the axe. So this I would encourage you guys to read this. The link will be in the slides when I kind of share them. So this is a great explanation of like the um uh the Mitnick attack. And so, I would encourage you guys to read this paper. And this is sort of also what I want you guys to kind of think of when you're writing your analysis. Like I gave you a little bit of a template, but I want you guys to, for the future case studies and stuff like that, keep in mind like what you want to always sort of start with early is like the technical tricks being used, because as a cybersecurity expert, a lot of people are going to come to you on the technical nature of things, right? So try to get familiar with that. Also, like the exercise which we do every week on like, oh, what attacks happened this week or the previous week. It's good to kind of try to get the technical nature of it. I had a tool here. I think it's, let me see if it's still up. But you can also use AI. Yeah, okay, there it is. So you can, this is an interesting mind map. So maybe we can use like one of the things we talked about today, right? Like, let me pick up I shared with you guys this trail bits, right? So this, I kind of like, so this is like, you can kind of always get to like the steps and the details using AI initially, but over time you'll also realize that, AI has its limitations, but this is one of the which kind of gets you a bit, where did yeah, a bit of like, okay, so this is sort of like the threat, the prompt injection in AI agents. And this is, let me see if this is still functional. Yeah, okay. Oh, sorry. Yeah. Okay. Uh, okay. So let me just give me 1 second and I will come back here. So just let me add the key here. I want to show you how you can use AI, and I'll give you a prompt which you by later today, which you can use to kind of like analyze the technical nature of things. Just 1 second. Okay. Okay. Um, Bear with me a minute as I kind of get the API set up here. 1 second. There it is. Second. Okay. There it is. Okay. Now also copy. All right. Is okay. There it is. All right. Okay, there it is. You see my screen now. So, um, so so what you want to always, and I'll talk a little bit about IOCs and like how you would kind of use those in your analysis, right? Like so, in case of Kevin Mitnick, can someone tell me what an IOC would have been? IOC stands for Indicator of Compromise.
Maybe the connection attempts with the incorrect TCP sequence numbers.
That's right. So if someone did like more than 10 tries, right? Like how you kind of, if you, in some password systems, if you enter your password like, more than 3 times in like a minute, it will kind of lock you out, right? So that's like a rate limited, but in case of Kevin, like just the attempt of it would throw a red flag there. Okay. So you will see like, this I again like this tool will be in your um uh PowerPoint deck here, but like the trail of bits, like the indicator of compromise will be like, oh, this CVE 225 54795 or something like that, or like a server name like seat evil.com showed up, right? Like you will sort of see. And then the techniques which were used in this attack are all like the MITRE attack techniques, which are elaborated here. In case of Kevin Mitnick, you can also sort of do the same one. When we come back, we'll talk later about, like, in case of Kevin Mitnick, how would that be? But I want you guys to kind of do something similar with future exercises as well. So you will see, oh, in this case, this is like, these are the techniques being used. This sort of gives you a little bit of an idea. Again, like, you don't have to use this tool, but you can kind of do the same with like existing AI tools as well. Like, hey, can you give me the for this particular URL, can you kind of give me you know indicators of compromise, the threat scope, things like that. So maybe um, you can kind of do that. I will fire this and then we'll take a break and come back in 10 minutes and we'll talk a little bit before we jump forward about like the same thing with Kevin Mitnick. So let me, I will add the link here and we'll come back to it. Okay. Sweet. Cool. We are at 10:12. How about we take a 10-minute break and we come back at 10:25 and we'll continue the the conversation here and we'll get into Wireshark capture filters and display. Okay. Um, Cool. All right, guys, we are going to take a break and we'll come back, talk a little bit about Kevin Mitnick in terms of the tool which I just showed you. And then I'll also will continue with Wireshark. Okay. Let me put a timer on and I'm going to pause the meeting recording. Hey, so let me share my screen. Let's quickly talk about um, so let's talk about, like, if you were to kind of use a little bit of AI to understand the Kevin Mitnick attack, right? Like what would that kind of give you? So before we did the break, I kind of ran the Kevin Mitnick attack um, with the tool I showed you. So, it's basically the art of IP spoofing, right? Like, like you will learn about ARP spoofing in your labs this week, or, similar things as you kind of saw in the attack for IP spoofing, right? And so the indicators of compromise in this case would be, the 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 frac files which he got, right? Like if they left the um, they left the machine, but not a whole lot of other indicators of compromise, like actually, make any sense, right? Like in that sense. Um, so the IP spoofing basically gave him a credential access, right, to impersonate as a trusted host and gain unauthorized access. So that's a technique ID, which is in the MITRE techniques, right? Then TCP sequence prediction is how he got his initial access, right? That again is a MITRE technique. Network sniffing, which is kind of what we would do with like Wireshark or stuff like that. Then he established a trusted relationship, and then he uh, installed a kernel module, the TAP 2.01. So that's how he kind of got persistence, right? And then manipulation of R hosts, which gave him a persistent backdoor entry. And then, the denial of service was done with the SNIN flooding, right? So this sort of is like a really good way for you to kind of start getting familiar with all the techniques in MITRE ATT&CK framework and things of that nature, because over time, this is just going to build like your toolkit of being able to find techniques to attack and find methods to defend, right? So this is a good exercise you can do with all the case studies we are doing in this class, right? Then you will kind of see, there's a little bit of like what's the execution time, like how did he start? Like, he start with IP spoofing. And so this is the kill chain. If I were to ask you, what was the kill chain for Kevin Mitnick? So this 1 to 9 is the kill chain what Kevin Mitnick used, right? Like, so it gives you a bit more color and technicality of how exactly he went from one thing to another. Um, and this you know the scope is kind of like a business scope, if you will, of the initial um, or actually the scope would be the scope of what he did and why he did, right? Like, that sort of stuff. So here you will see like this is sort of the colored version of like the MITRE ATT&CK framework, how he kind of used these. And you can kind of take a look in that way. But this, you don't need to use this app or tool. You could do the same with a AI prompt. So in the slides I'm going to share with you, I kind of gave you a AI prompt which would generate something like this. Let me go back to that and show you that. So here, you can use the Streamlit tab, but if you don't want to do the API keys or stuff like that in your, any of the AI tools you use, you can use, a prompt like this. Analyze the provided URL or uploaded file and generate comprehensive cyber threat intelligence components, process the content, and create the following selected output, like summary and a mind map of it, extract IOCs. So IOCs would include all of these kind of things. Threat scope, TTP's overview table, map the behaviors to MITRE ATT&CK framework, TTPs by execution time, and TTPs graphical line and the layer. So this sort of is, you can just use a prompt, something like that, with like any of the AI tools and see what it gives you, right? And feel free to kind of update the prompt and report back on what you kind of found useful or not useful, right? But this is one way by which you can kind of go a bit deeper. End of the day, what you want to get to is something which is like this, right? The TTPs by ordered execution give you a very concrete way of like how exactly this attack went on, right? Like, started with IP spoofing, network sniffing, TCP prediction, trusted relationship, then manipulated the R hosts, and then, was able to do persistent with kernel module installation. So this gives you a really good idea of like how sophisticated the attacker is, what exactly happened. And this is also how you should think of like evaluating any of the attacks which you kind of read on. Like, you might not know all the techniques, you might not have enough detail for things, but that's end of day, these are the things which kind of help you create a very credible defense strategy, as well as create a strategy for detection, right? Like how are you gonna, like if something like this happens on your system or a system you're protecting, how do you detect it, right? And so this is sort of how you do it. Cool. Okay, any questions on this so far before we jump? All right. Okay. Sweet. All right, let's jump to a bit more about Wireshark. And we'll talk a bit about filters. We talk about capture filters and display filters. And then we'll kind of go a bit deeper into those. Okay, and we'll talk a bit more about TCP dump as well. Okay. Let's, on a very high level, let's just talk about I'm gonna stop the capture. Okay. All right, let's talk about capture filters and display filters. So this is Wireshark. How many of you guys have not used Wireshark before?
I haven't really used it.
Okay. All right. Who else?
Me too.
I turned it on and looked at it, but never really just used it.
Okay.
I just recently started using it for
Okay.
the NCL.
Yeah, okay, great. You know, we're gonna have in your lab, you're going to use Wireshark, and then I'm also going to try to find a couple try hack me's for people to kind of do for additional points. What I want you guys to kind of, you know, you can install it on, I encourage you to install it on your machine and use it, but if you can't, your labs have it, as well as TryHackMe has it, okay? You know, with Wireshark, what you're really kind of doing it is it's sort of capturing the information on the network wire, right? Like, oh, it could be your wireless card, it could be your wired Ethernet, so on and so forth. So, however data is coming to your computer, it captures all the packets and all the bits of the data, right? And then you can kind of dissect it and look at it. So anything you're going to do for network intrusion detection, you are going to do at the level of analyzing the packets, right? And so Wireshark kind of gives you that you know, insight into what you're looking into. And then as we kind of look more into network intrusion detection, there are tools which will sort of build on top of like what you understand with Wireshark, right? So we'll talk about, you know, different tools which will help you, you know, do intrusion detection as well as prevention on the network level. But with Wireshark, so when you're capturing packets, you can capture the packets of from a specific IP or an interface or things like that. And when you kind of add a filter for that, it's called a capture filter. Um, so in Wireshark on your screen, you will see this capture um, here, and the capture here gives you capture filter, right? And so here you will see, oh, you know, I'm capturing from this this sort of, you know, thing, and I can add a capture, like, you know, a capture filter, and I can say, you know, um, uh, IP uh, IP filter. I'm just gonna say, and you know, I'm just gonna say, you know, just capture IP host only things going to google.com, for example, right? Like something like that. And then, so you will see, and I'm going to start this interface. I'm going to start, okay? Continue without saving, okay? And so, let me make sure. Okay, and so you will see here that, you know, everything here is going to this one IP address. This is 144.195, that sort of stuff, right? Like, so I'm going to, what happened here? Did I have something? Okay, yeah, okay. So, you know, that this only captures from a specific capture filter, okay? And I'm going to restart it, continue without saving, and I'm gonna do actually, where did the capture filter go? Filter, okay. Oh. Okay, there it is. And then instead of that, I'm gonna do that. Okay. So you will see like this sort of, it only captures from that, and I'm going to actually do that. So this is sort of like, you know, capture filters, so that it's going to only capture for that specific filter. And so the filters can be like, you know, Ethernet host, protocol, like, you know, IP, host, so on and so forth. Like you can kind of add filters for it. And the way they are sort of defined is like, you know, this way. So these are capture filters in Wireshark. And the capture filters only, this is it will only capture packets for those things. So, you know, so TCP port 80 is, you know, it will only capture things of that nature. So these are sort of packets captured only which meet these criteria. Kind of think of it as, um, uh, think of it as like a of a not a filter but a sieve, like, you know, only packets which meet these criterias are going to show up in Wireshark. Because what happens is, with Wireshark, it's just like a crazy amount of you know, packets you will receive. So let's take an example, like, you know, if I only want TCP port range this and this, let's see if that works. So I'm gonna add one more, and I'm gonna say TCP port range, and I'm just gonna say, you know, and you will see that, you know, start the capture, continue without saving. Let me stop this options. Okay, there it is. Okay.
Wait, did you modify it so it was only capturing those ports for the source or for the destination?
So this on both. So so this will be that, and so continue without saving. Okay, so you can kind of, okay, so TCP port range. I'm just gonna say, you know what? I just want TCP port 80. Okay. TCP port 80, like that, if I send like that. Did I hit? Okay, using this field. Okay. Okay. I'm using. Okay, yeah. Okay, so you will see that this, you know, I'm gonna say TCP port 443. So yeah, things are easier. So, you know, the way it's sort of getting, you know, information to Wireshark with a TCP dump is like the tool it is using. And that tool uses, you know, lip, I think it's called lip pcap or something like that, and the filters are kind of, you know, specific to this particular um, uh, library. Okay, so let's see now how that works. Why is this not? Did I do something weird? Okay, I'm just gonna clear all of this. I'm just gonna do this. I think I did something weird. Just 1 second. I'm gonna delete this tick. Options. Okay, yeah. Yeah, I take that one out. Okay. All right. Okay. So let me see if I have something here which goes to TCP. Yeah. So you will see that nothing these days goes to port 80. So you will, yeah, okay, there it is. So you will see here, you know, there is a SYNAC which went only the port 80. You see only TCP, which is port 80, showed up here right now, because that's what I have set the capture filter to. No other traffic is showing up right now, right? Like, so this is what a capture filter would do, because in that way if you're focusing on one machine, one type of a thing, you can use a capture filter to kind of do that. You will see only, like, you know, the port 80 are kind of, you know, captured. And so if I go here, I kind of go stop, and I'm just gonna say, sorry, I'm going to stop and then I'm going to say no package capture, that's fine, options. And then here, I'm just gonna remove all of it. And then I'm gonna start, and you will start seeing everything, right? So this is what a capture filter does. There is a lot more you can do with it. And as I sort of showed you in the best place to kind of learn about this is the Wireshark documentation. It's great. And then this is the same filter kind of syntax which is used by TCP dump, because both Wireshark and TCP dump use this PCAP library as I was talking about, and the format for the capture filters is used by that particular library. Any questions on capture filters? Okay. Okay, let's talk a little bit about display filters. So, display filters are completely different from capture filters. We already used them earlier when we were kind of doing uh, you know, the stuff like that, right? Like this. So when we are doing stuff like this, all packets are being captured. Only the ones which match the display filter are shown in this thing here. So the sieve is only for display, not for capture. So that's the big difference. The syntax is also very different. You will see, in capture, the syntax, we didn't have equal in capture. But in display filters, we have syntax like that. So display filters will kind of give you a lot more. So like, it will talk, we can do like protocol, we can do, IP address, we can do a whole bunch of different things with it. It's also it's also used, the syntax is same used by T-Shark as well. T-Shark is, you can automate things or kind of do command line. So T-Shark also uses it. It supports about 1,000 protocols and 174,000 fields across those. It's more like English like. So, you can kind of do stuff. Sorry, I keep forgetting myself. Let me pull up. Yeah. So you can do name of the protocol, name of the field, TCP port. Like, you can kind of have display filters for all of these things. So let me see. Quick and IP dot source is equal to, I'm just gonna say 8.8.8.8. Let me see if there is something like that. No. V84. Okay, there you go. So you will see now, can someone tell me what 8.8.4.4 is?
Google.
Right. What from Google though? It's the Google DNS.
Oh, I see.
So you will see that from that source to this destination with protocol quick, these are all the packets happening, right? And so this is on, what is this filter called? Can someone tell me?
Display filter?
Yes, that's right. So this is display filter. Okay. And so display, a lot of like these Wireshark challenges and things like that you would be, doing with display filters. And it gets quite like, complicated, but it's also super easy to learn about. If you're ever stuck, the documentation is great. You can always also use AI tools for it. But the important part is to kind of, be able to craft a query which will get you closer to what you're trying to do, right? And so, for example, I want to see protocol ARP, right? That from that IP source, there is probably none, right? But if I just say protocol ARP, and so source, so you will see that ARP doesn't have a destination. Can someone tell me why?
Because it's broadcast.
That's right. Great, great. So you will see here, destination is broadcast, right? And so, it doesn't, it's sent to everyone. So, and that's why you don't, you know, and so, I can kind of filter by, and I can say, and so it's not an IP, so it's a source, right? And so source, let me, and sometimes, so this is an Ethernet source, right? So ETH, ETH dot source is equal to, I'm just gonna say S, sorry, S, uh, let me see if this would work. So if, sometimes CB65, let me see if this works. Yeah, there you go. Source. So another trick is you can always apply as filter and select Ethernet destination. But we don't want that. We want, okay, yeah, Ethernet source. Why did that not work then? Okay, let me go back. Protocol is ARP. And Ethernet dot source is equal to I have to debug that, but that should work. Okay. That should work, but okay, I'll have to debug that. We'll come back to it. Okay. Oh, I think there is something wrong. Wait, yes, I'll have to fix it. Okay. So the cool thing you will see is like if the query is wrong, the bar itself kind of turns red, and that means like there is something wrong with the formatting or nothing was found, either of those. And if it's green, you will see the packets, right? So that's really cool about that. So, we'll keep doing a fair bit of display filters as we kind of go along. We'll sort of do those. There is a lot of tricks on like how to get fine grain with it. Like, there is a fair bit of Wireshark work in your final like challenge. So try to practice Wireshark, and especially like around display filters, because a lot of times you would get like a PCAP. PCAP already has the captured packets in it, and you're trying to kind of come up with like a story of what exactly happened, right? Like, so very many times if there is like a hack and you're kind of looking at in retrospective, the data you are going to get from that is the network capture, right? Like what exactly happened on that network, right? So you can kind of take a look at it. So there is a fair bit of reading to do, but what I'm gonna kind of do is let's talk a little bit about trying this with Try Hack Me. So learn here, you will see in the modules. Okay. So this is a pretty good Wireshark's module. The the all three are really great. I'm going to assign this to you guys so you can kind of see how it would work. The same stuff which we have kind of done. You will see, you can load a PCAP. A lot of times, you won't start with like how I'm showing on my machine, but you will kind of start with a PCAP file, which is nothing but like, um, uh, like a store of captured packets. You will kind of do TCP sniffing. Different protocols will have different, and then we talked about packet dissection, what each of these things mean. This sort of room, the Wireshark basic room, is going to get you pretty familiar with all of these things. You will do a fair bit of these uh, over time, but I'm going to assign this room to you guys for especially people who have not used Wireshark before. So keep that in mind. Let me just quickly see if there is anything here which I didn't talk about. And so, yeah, we did talk about all of that. And then let me see if the packet operations, this will do next time. Yeah, okay. Okay, so I'm gonna assign the basics room to you guys. Okay. Cool. That room will help you kind of get familiar with Wireshark. And especially if you're not able to install it on your machine and things like that. So the second thing, which is usually I do in the class, is there is a pretty good competition, a cyber quest. So let me show that cyber quests. Okay. US Cyber Challenge. Okay. All right. There it is. So how many of you guys have done cyber cyber challenge or cyber quest. It's similar to NCL. Have any of you guys done this?
No.
Okay,
Never.
let me. Okay, let me. It's funny, like how. Why is this? Okay. CC. So typically, I don't know what is going on with this, but if we were to look at, let's take a look at a old version of it. Okay, all right.
Search archive website. At the bottom one.
Yeah, just 1 second. Let me do this way. Okay, there it is. Hopefully. Okay, there it is. All right. So this is 2025. When did they go offline? Oh, wow. Okay, so they went offline in March. Sorry, April. Okay, so this, hopefully it loads here. Okay, so this is like an archive of the cyber quest, and I'll kind of give you, hopefully, they come back up or what's going on with them. Let's see. Maybe not that snapshot. Let's do this one. They're working. Okay, there it is. Oh, wow. Okay, yeah, this is spring 2025. That's weird. Okay. Oh, okay, it closed on March 31st. So, all right. So, this is usually a pretty good Wireshark challenge. If you've not done this before, this is a great Wireshark challenge. So the 2025 Cyber Camp has this. So there are all these older ones here. So maybe, let's take a look at the question engine. And then, so this is, it's got, okay, there it is. That's weird. You know what? Let's see if we can get to this one. Sorry, we're doing a live hacking session here. Okay, is this okay? So okay, let's see, the resource file will be great. Okay, great. What I'm going to do is I'm going to share maybe this resource file with you guys. So this is usually like really cool. So they share a PCAP with you. And so I'm going to open up this capture PCAP with like, with you guys. I don't need, so, this is a PCAP which that challenge had it, and it will have a few questions on like, how to look at this PCAP. I will try to get the questions for you guys, but basically, this is what they sort of share, and like you will see, these are pretty esoteric protocols in there, and the one always to look out for a little bit is SMB. And so SMB is, can someone tell me what SMB stands for?
That's the Windows protocol. I think it's Secure Message Branch.
Yeah, so it's a Samba share. It's basically Windows, file shared on a Unix network is SMB. And you will see here, you see, this like SMB, and you will see, oh, pad to this is admin. And a lot of times, and you will kind of see this in a lot of like, try hack me, hack the box, or any of the challenges, these Samba shares or SMB shares, you can kind of get admin access into it by usually doing like a password attack. And so here you see this 172.16.31 computer on this network is a Samba share, and you can log, and it has an admin here. Do you see that admin? Like, that admin. So you can kind of see like, oh, maybe something happened there. But like, this is the type of stuff you can kind of use to look on what happened on a network. So for example, if this network got hacked, you will kind of look at, oh, who connected to this Samba share, and then you can see what the source of that was and kind of reconstruct a whole bunch of stuff from it, right? And so this is sort of the power of Wireshark, if you will. There is a bunch of other stuff here. Let me see if this makes any sense. So yeah, so this is like maybe a phishing thing. So this is the latest quiz from the Cyber Quest. I have no idea why they turned it off, but we can possibly recreate it. Cool. Let me see. There's a US scoreboard. Okay. All right. Okay. So I encourage you to kind of take a look at it, resources file, and then there are attempts for each of the things. Let me see if maybe the cyber camp. Okay, cyber camp. Okay. Yeah, if there is interest in merit students at some point, we should join the cyber camp. It's pretty good as a learning, as well as it's a bit different than NCL. You kind of you get to actually be there and meet people and that sort of stuff. Okay. I guess they just changed the dates. So, okay. All right. Let me see if I can get you the questions for the camp, but I will share those Wireshark files with you guys to see if you want to like play around with those. And we should be able to get the files for it. Okay. All right. All right. Okay. And then what I'm gonna do is quickly yeah, I'm also, I want you guys to use try hack me as you can. I know, so especially people who've not had background before, the prerequisites is great. If you want to um catch up or go deeper into something you don't understand, please do the prerequisite. Let me see how many of you guys, I see that, 16 of the 20 users are active. Assignment wise, I know we assigned the um, pre-security to you guys. So, if you are new, I encourage, yeah, Craig completed the whole prerequisites. What did you think of it, Craig and Otis as well?
Yeah, I actually did it a while ago.
Okay.
So I didn't do it for this, but I I mean I think it's like it's a good introduction. Try Hack Me, some of the stuff is really good. Sometimes it's like a little bit, you know, the problems are just checking that you read it by asking for a particular keyword, um, which isn't, I don't find particularly useful, but like reading the material is useful and it's a good introduction to some of the concepts.
Okay, great. And Freddie, you also completed that, right? Yeah. Okay. So, I'm gonna ask, have you guys, do the Wireshark basics room? Okay. So so if you have questions, is everyone familiar with Try Hack Me? Is anyone having issues with it, or you good? Okay. Anyone need a Try Hack Me kind of primer? Are you guys good? Okay, I'm gonna take it as you guys are good. Okay. Okay. Uh, anyone not have access to Try Hack Me? Let me see here. Okay, cool. Everyone should have access. Okay. Okay. So let me then kind of get into what labs we are doing for next week. So we're doing a set of net labs and then Wireshark basics on TryHackMe. Okay. I want you guys to maybe read a little bit more on the capture and display filter. And this one is optional, so I'm not asking. So this is March 2025 packet captures. Okay, so this is optional for like, the CyberQuest packet captures. Let's talk a little bit about NetLabs and what labs I want you guys to do for next week. Okay. Is everyone clear on the Try Hack Me Wireshark's basic? It's pretty straightforward. It's sort of like what we covered in the class, and you will get a good idea of like, how to use the tool. You don't have to install it, but I encourage that you guys install and have it usable. Cool. All right, let's talk about NetLabs. No questions on Try Hack Me, right? All right. Okay. Let's talk about NetLabs. assignments. Okay. Okay, week 2. Okay, there it is. Okay, I'm just gonna say complete. Okay, so I'm gonna change. I think the link is bad here. So let's talk a bit about NetLabs. So everyone should have access to NetLab by now. Yeah.
I don't have. I don't have access, but I want to.
Okay.
I would go. I would go to the summer.
Okay. Who else doesn't have access? Let me see. Okay. So everyone here, I bash you.
Yes.
Okay. Okay. All right. Okay. Who else doesn't have access? Anyone on the list here doesn't have access? Okay.
Were we supposed to receive a password?
Yeah, you should have. Who is this?
This is Lisa.
Lisa. Yeah, you should have received a password, Lisa. Yeah.
Okay, let me.
In this email address. This is your email address.
Mhm.
Okay. Okay. Anyone else? Okay. All right. Okay. So we will look into that. Let's square away the NetLab. So this is sort of where you log in. Okay. openlab.bsec, and then this is a little bit of a dated tool, but it is sort of what we have for labs. And so there are 2 labs which will be, and I'll show you guys shortly here, which you will be doing. I'm going to okay. Okay. Oh, sorry. This is my bad. I am looking at the wrong thing. This is not even the week 2 assignment. Okay. Week 2 is this one. All right. Okay. So I was like, what is going on? Okay. Okay, so I have 3 labs for you guys to do this week, and we'll go through each one of those. Okay. So let's talk about the network analysis lab. So this is lab 6. Okay, and then I just want to make sure this was Bashu. Yeah, so Bashu, you do have access and you should have gotten an email.
All right, I
Okay. So check you guys' email if you don't, and if you forgot your password, you need password reset, please email me. And when you email me, include your student ID. Okay, if you need, everyone should have access. And if you're not able to log in, don't know where to log in, email me and ask for reset of your password. Okay. Okay, cool. All right.
I checked email and I don't have a password in the email.
yes, I know.
Lisa, this one, right? Okay. Lisa, this is your email. You should have email. But if not, email me and ask to reset your password. Okay.
Okay.
Okay. I am going to send you an email here. If any of you guys don't have an email or like need to reset, email me because it looks like some of you guys have not received an email, but the email was sent. Okay. All right. Okay, sweet. So you should see this lab there. And so the way to kind of use NetLabs is, in your classes, you will see the class, and what you want to kind of do is view the class, and then, view the reservations is what I do, but I'm going to, okay. Okay, all right. It's all set up right. Okay, so in the content here, what I want you guys to do, you will see like content like that, and you have access to NDG Series 1 to Forensics, Network Plus, and Security V4. And so in each of these, there are only a few labs I want you guys to do. So the first lab I want you guys to do is NDG Hacking version 2, lab 6. So here you will see this one here. Okay, my NetLab, new reservation. Okay, and so I'm going to pick up this one here. And so here I want V2 series, and I want you guys to do, which one did I say here? Okay, series 1, lab 6. Okay, my bad. Series 1. So lab 6. So this lab is the lab I want you guys to do, and you will see that each of the lab has like a write-up associated. So you're basically you're doing to capture traffic with TCP dump. You're going to analyze the traffic with Wireshark. So TCP dump will kind of, you can use the the exact commands and everything is in here. So all the capture filters, you can use the same ones with TCP dump. And in this case, you're going to capture from Ethernet 0, and you kind of do the network traffic, and then you're going to access like a SMB client and kind of create some traffic which is being captured with TCP dump. Okay, so once the traffic is captured, you're going to open up Wireshark. You will open up that capture file which you just created, and you're going to look at like the TCP stream. So that's basically what you're doing with lab 6. Okay, so that's the first lab you're going to do. The second lab you're going to do is lab 4 from Security Plus. And so all right, I'm gonna pick this. So here, Security Plus V4, there is Lab 4, which is investigating the ARP poisoning. So very similar to what I was showing with the ARP, you will see that, someone's sort of like, trying to say who they are not on the network. So this is a man in the middle attack. And so, you follow the instructions in this lab. You will have a Kali Linux box. You again kind of, set up so that you're doing ARP spoofing. And then, you can kind of look that ARP spoof in Wireshark. So that's kind of the exercise in uh, 2. It's pretty straightforward. You just follow the commands, and at end of it, I'll tell you what I want you guys to do. And the last one, which is lab 22, in the same NDG Security V4, is the lab I want you guys to do, is capturing network traffic. And so this is also fairly straightforward lab. You're going to capture with a TCP dump. In this case, you're going to do ICMP and ARP, and then you're going to use SFTP as well. So there are a few things you're going to do in this lab to kind of access the setup. Okay, it's you will see it. And this is a great setup because here you will also get you will kind of look into like Windows and IIS and things like that. It's a little bit longer, but it's fairly straightforward. Okay, so I want you guys to kind of follow all the instructions and complete this lab. Once you complete the lab, your deliverable for the week 2 is for the try hack me, and then all the labs on NetLabs. So this is NetLabs, what we call. Okay, so this is OpenLab BACC.net. So 3 labs and then 1 try hack me. I want you guys to write a I'm just gonna reduce it 2 to 3 page reflection essay on what you learned from the lab, and how it relates to detecting intrusion. So it's very straightforward in terms of like, using TCP dump for like different protocols like ICMP, ARP, and things like that. And then how do you kind of look in Wireshark for each one of those. In total, these 4 labs have 100 points, so 25 points each. And your deliverable is this reflection essay. Same thing for previous Try Hack Me. If you completed Try Hack Me, I'm not going to look into Try Hack Me if you have completed or not. I'm going to look in Canvas whether you submitted a screenshot or where you kind of talked about completing the Try Hack Me as well. So I'm not going to go by the completion in Try Hack Me, but all the completions are based on what you submit in Canvas. Okay. Preferably submit everything as one PDF instead of like separate files. That would be great. This is due next. Why did I? Yeah, sorry. It's due next Friday by 9 a.m. Okay. So this is the lab which you have for week 2. And any questions on this lab? All right. Is that clear?
Yes.
Awesome. Awesome. Okay. And I'm going to introduce a couple things so that you have enough time. So we'll kind of have like an intrusion quiz, like, kind of similar to like what I showed you with the Cyber Quest, where you kind of have a problem to solve. Um, but I also want you guys to try and do like a real life scenario as well. We talked about it in the last class, like we talked about these pathways, right? Like we talked about this security analyst level 1, right? Um, I encourage you guys to try and do some level 1 assignments, just so you get a feel for it, because I'm gonna have you guys kind of do it with like a real life sim, like maybe Elastic or some of other sims. So if you go to Try Hack Me, they have like a whole a path which is SOC level 1 analyst. So this SOC level 1, all of you guys have access to this path. And in this path, you will see that, there is and we'll start with Snork and Zeek next class, but you will see that there is like a ELK, Elastic Logstash and Kibana 101. So this would be a good one to kind of start to get an idea of like, what it means to kind of see intrusion in real life. So, and then there is and TryHackMe is really good for that, because they also have like a whole SOC simulator where you actually see, like, if you were in a security operations center of a company, how can you spot like there is an intrusion happening right now, right? Like, or that an intrusion could be happening right now, right? Like, so the good one to kind of get a bit more uh, familiar with is the ELK 101. This one, this is not required, but it kind of gives you an idea of like, Elastic, Logstash, and Beats and Kibana, how they kind of like come in together to kind of give you an idea of like of the logs coming in from your servers and such. So I encourage you guys to kind of review that. We will be doing a whole uh, exercise around this. So uh, I'll introduce that to you over time, but if in order for you to get started, kind of take a look at that. Okay. Cool. Let me see if there is other stuff. Okay. Okay. And then your quiz for this week, the quiz will be open right after the class, and it is due by Sunday midnight. It's a pretty simple quiz on TCP/IP and hex. So this is the quiz which will be available now, and it's due Sunday midnight. So let me quickly show this quiz to you. It's pretty straightforward. Okay. All right. So it's got 5 questions, you know, about addressing, routing, so on and so forth. So you can. Okay, yeah. So what is the hex of this number? Which layer is addressing and routing? What's the hex representation of this IP address? Which of the following protocols operates at TCP IP model? You know, how many bits are in a single hexadecimal digit? So pretty straightforward. I expect you guys to be able to do it in like 15 minutes or so. But that's your first quiz. Cool. 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 One other announcement I have is EO. You're on the call, right? Okay. So EO is your teaching assistant, and he's available Monday 6 to 9 p.m. and Wednesday 10 to 1 p.m. And you can use this Zoom link to meet with him, but I also encourage to schedule time with him on Discord during this time. What I'm going to do, not this class on, but next class on, as you kind of get more homework and more projects to complete, to have you guys meet one-on-one with me or EO. Okay, so I'm gonna require you guys to do it. Um, you know, I'm just gonna say one-on-one meeting. So make sure that you plan for like at least 15 to 20 minutes of one-on-one meeting between with me or EO. And as you kind of do it, we'll kind of mark you here as you sort of complete it. Okay. You can it is not in person. The meeting it will be on Zoom. There will be not the next class, but the following class we will be doing in person. So let me also just do that. So November 7th will be in person. And let me November 7th class will be in person. I want to maybe just do it this way here. Who all can make the November 7th class in person? Okay, Craig can. All right. Sure, now can. Okay, let me quickly. Yeah, why don't you guys? So Rob, can you as well? Yes. Yeah, Rob can. All right. Lily can. Uh, we got 5. Who else? Okay, we want to try to get to at least 7 or 8. We got a class of about 20 students. So it'll be good to at least get up to 40 or 50% students in person. Okay. All right. Frazenda, Lisa, Odis, Carlton, Bashu, Anish, Anyo, any of you guys can make in person on November 7th, not the following week, but the one after that.
I'm not sure, Mr. Professor. I live far enough, but if I could, I would keep you posted.
Okay. Also, a heads up, like this is probably one of the fewer times Merit is gonna do classes like, completely online. We'll be moving to in person. So I just feel like, it's gonna be better if you show up in person. Okay. Lisa, you can, right? Okay, awesome. Okay, great. Yeah, keep me posted. I'm expecting at least 7 or 8 of you guys to show up in person. So please, uh, make sure you kind of plan for it. And I just see Rob saying he's signing up to bring some breakfast. Last time he brought like donuts and um, bagels. So thank you, Rob. Thank you for signing up to do that. Appreciate it. Awesome. Sweet. Uh, cool. So other follow-up I have is, and this especially for people who are watching this on recording, we're gonna try to make sure like students who don't show up in the class, or students who have not been engaged, don't get a fail on their record after the class. So I'm going to drop the students who have so far not shown. So if I do not hear from the students I have marked red in the spreadsheet by Monday, I am going to drop you from the class. If you're watching this on record, then please email me if you don't want to be dropped. And not only that, make sure you complete at least one assignment, okay? Um, let's do that. I just see a message from, how do you say Tavi? Tavi, is that right? Okay, I'm gonna make sure you get access. Yeah, I think I gave you access to TryHackMe and NetLabs. Do you have access to TryHackMe and NetLabs? Okay, why don't you email me so that you get access to NetLabs and TryHackMe, okay? Please email me. Okay, please email me and I'll make sure you get access here. So continuing on the previous conversation here, like students who are marked red here, I am going to wait until Monday before I drop you from the class. If I do not hear from you by Monday, so sorry, Peter, you already, sorry, Peter, you're good, sorry. Peter, you're good. Okay. So I am going to drop the students Uchenna Voni, if I'm saying it right. Okay. Cesar, you're good. Okay. So students who are marked red, and if you listen to this on recording, please reach out. We will be dropping you Vivian as well. Okay. All right. Okay. So we got 1, 2, 3, 4, 5, 6, 7 students marked red here. So if I don't hear from you by Monday, I'll be dropping you from the class. Okay. Okay. All right. Cool. Let's see what we have more. Okay, let's talk about the case study for next class. So you have a case study, a lab, and a quiz. Okay, so the case study for next class, and you, when I share this deck, you can use some of the stuff which we kind of covered in this deck, or like any of the AI prompts or things like that. So the case study for next class is the 2000, let me bring it up. So the 2013 target breach. So it's very specific, okay? I'm gonna take this one out from here, but yeah, so the case study for next week is 2013 target data breach. I will, there been some other breaches. You will, the reason it's a little bit older is like you kind of see, it's a well-studied breach, so you kind of have enough different viewpoints to kind of learn from it a bit more detail. So, about 40 million credit and debit records were kind of breached in 2013 from Target. And so this is the breach we are talking about. Okay, I want you guys to kind of, do an analysis of that breach. You can use the template like the last time. You can also add the elements which we talked about in today's class, like, IOCs and the kill chain and things like that. So that will be the quiz, that will be your case study. So you have case study, lab, and then the quiz is due Sunday evening. Okay, so that's your work for the class today. So homework, the case study, labs, first set of net labs, and then Wireshark basics on Try Hack Me, and then read Wireshark capture and display filters, and then practice your skill with CyberQuest March 27, 2025 packet captures and files. I am going to put a link for those in here. Those are not required. It's an optional thing if you want to try with your Wireshark. I'll find out the questions and the links, and I'll add them in the deck here. Okay, they're not required. It's something you can just sort of practice on. So I will share those files in the link in the deck. Okay, uh, sweet. Okay, cool. Any questions on this review so far? Okay, great. All right. Eob, do we have you? Are you in the class here? Okay, I guess he's not in the class. So what I'm gonna do is for next 5 minutes or so, I'm gonna make sure like people who email me or people who have not been able to access NetLab or anything like that, I will be around to kind of make sure you get access. I'm also available for one-on-one office hours until 1:30 p.m. I know you guys have like a 1 o'clock meeting, oh sorry, a noon meeting for the club. So and you're welcome to go attend that. But I'll be on the Zoom. I'm gonna stop the recording in a minute or two. But I will be on the Zoom to help you guys with any of your Try Hack Me or NetLabs issues. And then I'll be also happy to do office hours. Any questions, comments, please feel free to chime now. But if not, I'm gonna give you 5 minutes early break here. Any questions? So someone has a question that if so is there an IRC? So Discord is how the students talk to each other. So if you do not have Discord account, in the last announcement I sent, I kind of gave you the sign up instructions. So Discord is where everyone is. So Discord is for all the students. So there is no IRC, but there is a Discord.
Hey, I have a question.
Yeah, go ahead.
Do we still have access to the AWS accounts?
Say that again, please.
Do we still have access as students to the AWS accounts?
Oh, from the cloud class?
Yes. Is that only available in the cloud class or?
Yeah, it's only for people who took the cloud class last, 6 weeks. They have access to the AWS cloud stuff. So it's part of the CIS 52 class. There is no AWS in CIS 53 or this
Okay.
class. Yeah, so for Discord, yeah, you will just make a new account and sign up. That's the best way to go about it. That's where all the students are. So cool. All right. Any other questions? Okay, cool. All right. If not, then I'm gonna stop recording, but I'll be on the Zoom here. And then if you have any questions with regard to TryHackMe or NetLabs, please email me. I also want to remind that on the screen you see the students who are marked red. They are scheduled to be dropped from the class if I do not hear from them by Monday. Okay. Sweet. Cool. All right. I'll see you guys. You do have a fair bit of labs and homework, so stay around, do those. Share anything you learn on Discord. If you have questions, please post on Discord. Office hours are for the TA are also available. So make use of those too. Okay. Cool. Awesome. Thank you, everyone.
Have a good weekend.
All right. Have a good weekend, guys.
Thanks. See you
Yeah.
next week.
Yeah. See you guys.
Thank you, Professor.